This recording is Discrete Probability Theory. It's by our group 1. It is an introduction to discrete mathematics for the course MAD 6108.
Our topic, discrete probability theory.
My name is Elma Baton.
Murray Barrazo.
Oscar Robinson.
The course description for discrete probability. Discrete probability is a fundamental course in the field of mathematics that focuses on the study of probability and its application in a discrete setting. The course provides students with a solid understanding of foundational concept, principle, and technique of discrete probability, enable them to analyze and solve problems related to randomness and uncertainty. Now, the 4 concepts that we will be going through: Session 1 is discrete probability spaces. Session 2, conditional probability. Session 3, independent event, product spaces, and the binomial density. Session 4, dependent trials and tree diagram, and Session 5, random variability and their density function expectation. Our learning objective will include everything that we learn in discrete mathematics: understanding basic concept, computational probability, probability distribution, conditional probability, independence, law of large number, random variable, and expected value, including joint and marginal distribution, random sampling, limit theories. These objectives provide a foundation for understanding and applying probability theory in various fields, including statistics, data science, computer science, and decision-making process. Prior knowledge. In order to understand this course, we need to activate student prior knowledge in basic mathematics, set theory, counting principle, logic and reasoning, algebraic manipulation, basic statistic, mathematical proof technique, and we may include a little bit of calculus. TPAC stands for Technology Pedagogy Content Knowledge. It's a framework that describe the knowledge and skills teachers need to effectively integrate technology into their teaching practice. TPAC emphasizes the intersection of 3 essential components. So the 3 essential components is technology, pedagogically, and the content. And as they intersect, we should have the benefit. Let's talk a little bit about the benefit of TPAC. It enhances teaching and learning. It increases students' engagement, improve learning outcome, and professional growth and future-ready skills. TPAC provides a framework for integrating technology in education that goes beyond the mere use of technology too. It helps teachers leverage technology in pedagogically meaningful ways to enhance teaching, engage students, and promote effective learning outcome.
In terms of technology and knowledge, this section has many opportunities for growth in terms of using technology. We begin with the obvious, which is one of them is Math Excel, the Pearson Math Lab, and the Khan Academy. Those are just basic practice exercises. More recently, we have also used the TI-84 graphing technology, using Excel spreadsheets or creating and using computer algorithms. In this class, we also have focused on using GeoGebra and GeoGebra spreadsheets to prove many of the concepts learned in this lesson.
Pedagogical knowledge. Basically, this is actually to understand the needs of our students. In discrete probability theories, we're going to use several things to assist us to understand the student's need. Teaching and learning strategy. One of the teaching and learning strategy we're going to utilize hands-on activity, interactive demonstration, real-life example to engage students in understanding the concept of discrete probability theory. Our instructional method will be step-by-step explanation using visual aids, such as a diagram or table to engage group discussion, and enhanced lesson. Our classroom management will create a positive and inclusive learning environment where students feel comfortable asking questions and participating in class discussion. Our assessment technique we will do formative assessment, we will do summative assessment, and this was enable us to evaluate students' understanding of sample space, event, probability measure, binomial theorem in probability theory.
Content knowledge, the framework from which our students will gain understanding for discrete math. The 5 parts. Number 1, discrete probability spaces covers the fundamental concepts of discrete probability spaces, including sample spaces, events, probability functions. Conditional probability explores the concepts of conditional probability as application in calculating probabilities of events given certain conditions. Independent events, product spaces, and the binomial density discusses independent events, the concept of product spaces, and the binomial distribution, which is used to model the number of successes in a fixed number of independent trials. Dependent trials and tree diagrams focuses on dependent trials and the use of tree diagrams as visual tools for solving probability problems involving dependent events. Random variables and their density function. Expectations introduces random variables, their probability density functions, their expectations, mean values. It covers topics such as discrete and continuous random variables, probability distributions, calculations, and expectations using these distributions. Now, in addition to that, students will be able to distinguish between discrete random variables, continuous random variables, how to determine if a distribution is a probability distribution, how to construct a discrete probability distribution, and its graph.
So some examples that we have provided in GeoGebra include, starting from the beginning, a simple Venn diagram where you have 2 sets, as you can see here, and you would basically go into the sets and you would select the correct distribution. So I'm going to come out of the PowerPoint for just a moment and share with you the actual book diagram. And let me show you how this would work. So at this point, what you can see is I have set P and set Q. This one has a letter A, B, C, D, E, F, G, H, I, and this set Q happens to have I, A, I, O. And if you notice, there's only 2 letters that are shared. So we know a student would have to drag the A and the I over into the intersection part, which is right here. And then finishing off the Q, finishing off A, B, C, D, I. And so in this example, we would have the B, the C, the D, and so they would have to drag the elements to the appropriate Venn diagram. If you notice, I have purposely deleted some. I don't have all of them. I did that on purpose to make them to critically think as they're doing the activity, and they can discuss this together as teams. You can also talk about using a highlighting. So for example, right here in describing using the notation for intersection, what is meant by P intersect Q? Well, P intersect Q is right here. It means set of A and I. And also, what does it mean? What is shown where we have not P versus not Q, versus not P and Q, which basically means we're eliminating the entire diagram. And so in that case, the student could be able to share and discuss that and write that out as well. So one of the activities that we presented as well, similar to the previous activity, is we're using drag and drop. We're using organizing the elements. We're talking about using spreadsheets. We're talking about notating and not note-taking, and obviously vocabulary builder. And then in this case, you can see that I do have another set of P and Q, and I'm asking a series of elements and how you drag them into the Venn diagram, very similar to the previous activity. you will see that students are reviewing not only the notation, but they're also discussing what some of the wording is. So like in example number 4, you see P or Q, and I also have P or Q. So these two we know should be matching. We also have P and Q, and I also have the symbolic notation of that. We also have not Q or not P as well as not Q, and then we also have their antithesis. So students will have a chance to use a spreadsheet or a sample sheet or GeoGebra, depending on what you choose to use, of a way to show all of these at some point.
The formative assessments for discrete probability theory can be designed to gauge students' understanding of key concepts, problem-solving skills, their ability to apply probability principles. The formative ongoing assessments used are conceptual questions, problem-solving tasks, scenario analysis, 6-question quiz, group discussion on presentation. The expected outcomes of these formative assessments are for students to develop a strong conceptual understanding of discrete probability theory, apply probability principles accurately, demonstrate problem-solving skills, and effectively communicate their mathematical reasoning. These assessments provide valuable feedback to both students and instructors, allowing for targeted instruction and further refinement of students' understanding in this field. So formative assessments are quizzes or small assessments used to show student progress and give teachers the opportunity to make adjustments. And here, generally, you can make it as long as you want, but ideally it's going to be short in comparison to the summative. So here we have a 6-question formative assessment. Some of it is multiple choice, or you could opt for fill in the blank if you wish to go deeper into the student's understanding. Summative assessments for discrete probability theory aim to evaluate students' overall knowledge and skills in the subject area at the end of a unit or course using a written exam. The expected outcomes of these summative assessments are for students to demonstrate a comprehensive understanding of discrete probability theory and its 5 components, apply probability principles accurately and effectively, solve complex problems, and communicate mathematical ideas clearly. These assessments provide a holistic evaluation of students' knowledge, skills, and abilities in the subject area and help measure their mastery of key concepts and techniques in discrete probability theory. The teachers, when using summative assessments, also have an opportunity to go back and refine for future use. Summative assessments, and with this one, as stated before, summative assessments are going to be more comprehensive, so done at the end of the unit, which means they're typically going to be longer because there's a couple of questions for each attribute or characteristic covered. And it varies from multiple choice, open-ended, or the combination if you choose to integrate questions in that manner. We also have the ability to provide the answer upon the click of the question. The summative is also a great way to gauge for the teacher how well the information was delivered. Focus and attention of students independently will determine how well the information was received. Obviously, minimizing distractions.
Skills gain. At the end of this course, after we have utilized the TPAC effectively using our GeoGebra activities, and we will conclude the chapter. In this chapter, students will have learned how discrete probability spaces can be used to model experience whose outcomes are subject to random variation. The key concept that the students should be proficient in at the end of this chapter is discrete probability spaces in a sample spaces with probability assignment, an event in a subset of a probability spaces, computing the probability of an event in a uniform probability space among to accounting problem. Conditional probability, we're going to use a formula P, a probability of A such that B equals the probability of A union B divided by the probability of B. Independent variable, which is the probability of A intersect B, is equal to the probability of A times the probability of B, and understanding mutually independent events. Our reference consists of the following, including the textbook of this class. Thank you for sticking to the end of our presentation.